So let's talk a bit about game modules and how the modules and target system works. And I might just going to make this file a blank file so I can do some on the fly. Did I actually write this down? No, I didn't write this down. So if you look at the system on the right hand side, you will notice we've got like a build CS file and a target CS file. And if you look at the documentation on how the build system works, you will notice that there are things called modules and there are things called targets. This is why I didn't want to. This is why very early on I was like, I shouldn't call the other thing that I was referring to modules, because 5 hours from now it's going to get very confusing. So your modules, you can have engine modules, you can have plugin modules, you can have game modules. So in this case, we've got a game module. The game module is called test project. We don't have any plugin modules, like project level plugin modules. We don't, but we have engine modules. These are the ones that shipped with the engine, and unsurprisingly, they happen to have the same names that are listed in here. So like core is an engine module, for example. Engine is an engine module. Input core is engine module. HTTP is an engine module. And so modules are basically like these self-contained, well, they're self-contained modules. I don't know how to better describe that. But perhaps the best way to describe it is like if in C# you create a new C# project and you make it a library project, right? And then you can reference that library from other libraries or other executables. That's a pretty good analogy for what modules are here, right? They have all their code inside them. They have like a public and private interface. We don't see the public and private in the game because the game surface area is normally public. But if you look at some of the modules in each of these is a module, right? If we look at some of these, you'll notice they have public and private, and you'll notice that the public interface is smaller than the private interface. So there's a bunch of internals inside each plugin, each module, that you can't really access unless you do sort of like the header offset magic stuff that I was talking about earlier. So there's a bunch of internals that are, they exist with the intention that you're not going to be able to access them, right? And this helps keep the code self-contained and make sure people aren't like accessing all of this internal stuff that they shouldn't be using, so on and so forth. Now, that's all well and good. We've got all of our modules with all their code, all their surface areas. Modules will have public modules they depend on, private modules they depend on. The differences here are like, if I add a module to in the private dependency list, what I'm saying is that the only places where I'm including headers from these modules is inside my private folder, right? So if something else, say someone depends on me, right, and they're going to use my public headers, by putting it in the private dependency module, I'm saying the people downstream that are using my public surface area don't need to know these modules in order to use my stuff. If I put it in the public modules, if I put HTTP in the public modules, right, what I'm saying is, like, in order to use my headers, if you depend on me, then you must also depend on the headers available to the HTTP and JSON libraries so that you can resolve all the types. So that's the difference there between like the public dependency module names and the private dependency module names. It's about whether or not the modules downstream from you that are using your public API need to know the headers in order to use your public headers. Yeah, so that's what these do. So we've got our modules. We'll code it. Then we have these things called targets, and the targets are, well, typically you're going to have, if you're doing just like if you're just using like the installed engine build from the launcher, you're going to have a game target and you're going to have an editor target. Now, a game target has no suffix on it by convention, so it's just a test project target. You'll see that the target type here is game, and we have an editor target, and then we have a target type of editor, and it has this editor suffix on it. Now, if you are using Unreal Engine from source code and you're building the engine source, you have two other targets you can also refer to: server and client. And these are used by games that are dedicated, like you use server if you want to build dedicated servers for your game, and you use client if you only want to connect to dedicated servers, right? Game includes all the client code, but also all the server code so that you can host like listen servers and player hosted servers. If you don't want that in your game, then you can use client. And that means all the server related code will get stripped out of the binary when you send it to players. So players, they can't host their servers, but they also can't see any of the server code that you would need to get, you might want to strip out of the binary, so that players can't see what's going on. So that's what the targets do, and that's why you will have, typically have multiple targets here. Targets are also ways of configuring how all the modules involved are compiled. So if I go in here and I say project definitions.add test equals 1, right? So here I'm adding a C++ define test is equal to 1, and this is available to all of the game modules, right? It's not available to engine modules because project definitions is strictly limited to non-engine modules, and that's because, if you're using the engine from the launcher, you don't want to rebuild, or you can't rebuild the engine modules, right? So there's no way to add a define that's going to impact engine without rebuilding the engine, right? So project defines will affect all of the game modules, all of the plugin modules that are at the project level. So if you put a plugin in the project directory, these will propagate to those plugins as well. And so you can think of like targets as like the global configuration that you're applying to all the modules involved in the build. The modules can also, there's another type of module which is important for linking with third-party code, and that is an external module. So all of these modules that we've talked about up here, they have code associated with them, right? But if you imagine that you want to, say you want to link against any third-party library really that isn't written in Unreal Engine, right? So, well, in my case, like I developed the EOS plugin, right? So the EOS SDK, which is just a plain old C SDK, for me is an external module, right? I have an external module that basically configures how I link with the EOS SDK and where all the headers you are located for the EOS SDK. I think if we go into this third-party folder, we might actually be able to find, excuse me, a few examples. Oh, look, here's the EOS SDK itself. I know that one's a bit more complicated, so I'm not going to go into there. Free image? How complicated is free image? It's not too bad. It's probably all right as an example. So the first thing you'll notice is that the module type is external. We're saying, okay, here's where you find the includes for this third-party library, right? So any module that depends on the free image module is going to get these include paths added to its search list. So you can, from the modules that want to use free image, they just have to add free image to their list of like private module dependencies, and then they get all of the libraries and includes that are relevant for free image. And then we have some logic that's around, okay, let's find the free image binary. So you can see on Windows, it's going to be a DLL. On Linux, it's like a .so file. On Mac, it's a .dylib. Pretty much what you would expect from dynamic libraries if you've ever done any, like, if you've ever linked against like third-party native code in like C# with like pinvoke, you will be used to seeing this if you've done cross-platform stuff. Fairly standard. This public delay load DLLs, how do I explain this? So when the operating system loads your application, so let's say you link against a DLL, right? When your application launches, what will happen by default is the operating system will locate the DLL that you depend on and load that into memory at the same time. And it will make sure all of the functions you call are all like, calling into the right places and everything is linked up correctly. Because of the way Unreal ships its game layouts, that doesn't really work because the DLLs don't end up in the right place. So we use a thing called delay loading, which is basically a way of saying, okay, I'm linking against this DLL, but I don't want the operating system to try and load this DLL for me. I'm going to load this DLL at runtime. And so all of the functions just are left as stubs. They will crash if you try and call them until you do the work to actually load the DLL at runtime. I really hope that I can actually just find an example of what this looks like. Yeah, I reckon it's going to be in this define here. Free image libdir. Now this might get a. Oh well, no, we've kind of got here. So, you can sort of see. Okay, this code here wants to use free image, and typically you would encapsulate this into like another module that would be responsible for like loading and unloading the module, loading and unloading the third-party library when the game starts up and shuts down. In this case, it's just seems to be very much like on demand if needed. So we find the location at runtime. We're finding the location to where that library file is, and because the way we've set up this build.cs, we're setting this free image lib file name is going to be set to file name, which is going to change depending on the platform that we're building for. So that way we get, free image.dll on Windows and, lib free image whatever on Linux. We push and pop the DLL directory so that the search paths work correctly. And then we basically tell the operating system, hey, please load this DLL and, give us a DLL handle. This is just like void pointer, which is just basically an untyped pointer. The only reason that we basically have it is so that when we finish with it, we can, we can release it. I'm not sure this code has, this code doesn't do any release, it just loads it and leaves it around forever. But you can use the handles that get DLL handle gives you to then unload the DLL later if you want, which is what I do in like my EOS code. I do the proper startup and shutdown lifecycle of the DLL when the plugin starts up and shuts down. And yeah, that's modules, targets, how you reference external stuff in your Unreal Engine code. If there are any questions for that, feel free to check them in the chat. Otherwise, that is going to be a wrap. I don't see any questions in chat. So can you talk about the modular game features? I'm not across modular game features, so I can't actually speak about them. I think they're new in 5.0 or 5.1. But yeah, I'm not across them at all, unfortunately. I know they were heavily used in the Lyra example, I think. But yeah.
All right. Well, that was great, June. Thank you very much. It was just a whirlwind tour of the ins and outs of Unreal and C++. It was pretty amazing. I think I can speak for everyone to say, that was just very enjoyable, very thorough. And I really appreciate you taking the time and effort to convey this knowledge to us. So thank you very much for that. I'm definitely going to have to watch the videos again. I feel like I should have just been taking notes this whole time. Like I was back in uni. I was just like, I feel like I'm missing a lot of good stuff here. But that was absolutely great.
Yeah. We had a question. Are you familiar with the replication graph? I've heard of it. I haven't looked into how it works. I roughly know what it's for. It's basically so that you can control specifically what you want to replicate more with like more fidelity than just what the standard replication system gives you. But I haven't used it myself, so I couldn't possibly opine on the APIs there. I will chuck my mastodon.social handle in the chat. It's mastodon.social/HQ. Actually, you know what? For the purposes of the video recording, I will also put it on screen. If I can figure it out how to use. See. Yeah, here we go. Yeah, there we go. Cool. Now it's forever preserved. So yeah, so if you wanna follow my random ramblings on programming or any other stuff that I randomly put up there, that is a place to follow me and my stuff. Yeah.
Excellent. Yeah, and thanks again, dude. That was just, remarkable. And an excellent effort on your part. I appreciate you putting in the hard yards there. It was, what were we at, like 7 hours? 7 hours?
7 hours, yep.
Yeah.
7 hours.
It's something else. That's crazy. Yeah, but so enjoyable the whole time. Yeah.
Yeah.
So thanks again, Jude. Yeah, I guess we'll wrap up the stream here.